Thanks, Gav. Thanks everybody for coming. I don't get to speak to the Victorian branch very often. I think the last time I did was when I was president of Aares, and the branch. Before you go, Gav, I want to give you a bouquet. I think it's great to see the Victorian branch doing so well. I wasn't doing nearly as well as I was the Victorian branch president, and I think Dave and Gavin have really done a good job, even though they're sometimes a bit careless in their choice of speakers. So thanks for that. And the last time I did speak, I think, was when we were trying to build the branch up by being entertaining. We held a debate, and I can't remember what the topic was. The only thing I can remember was Bill Malcolm, who was the opposite side, and he accused me of being a cunning linguist. Which I thought was harsh, but it relates to today's topic because see this Splendide Mendax. That's Latin, and I don't know how I found that, but it means it's a life for a good purpose. Is what Splendide Mendax means, and so that's what this is about. At Davis, the reason you have these handouts is because you probably won't be able to see what's on the screen here. I'm sorry about that, but I come to depend on these things for how I do talks. On the front here is I direct the Robert Mondavi Institute Centre for Wine Economics. I've got this Centre for Wine Economics that I took on. Jointly, I made a decision to do a project on Pierce's disease of wine grapes. And I've been working on that with Kate Fuller, who did a dissertation with me. She's still working here. She actually works at Davis. He's retired now, but he was a winemaker for about 20 years, and he taught winemaking at Davis. And he hangs around the Agricultural Issues Centre with Dan Sumner and me. And Kabir Tumba was a research assistant. He's gone. And George Salias works at the Liquor Control Board of Ontario, Canada, and he played a useful role in giving us some data. So lots of people involved in this. I took on this Centre for Wine Economics. I said, if I'm going to do this, there has to be some funding, and I got funding to do a project on Pierce's disease in the wine industry. Pierce's disease is a bacterial disease of wine grapes spread by these xylem-feeding insects called sharpshooters, and it's been in California forever. You can see this blue-green sharpshooter lives in the Napa Valley. It doesn't fly very far, and it infects vineyards at the edge of riparian areas and causes big losses every year, but not it's chronic. And then 10 or so years ago, these aren't to scale, but the one on the right, it looks nasty. That's the glassy wing sharpshooter, and that came from somewhere down south. And it flies a lot farther. It can do a lot more damage, and it devastated the wine growing area in Temecula in Southern California. And so they set up a program to control this thing, to control the movement of grape material in the state, spending a lot of money trying to manage this thing. And they asked me to do a project to evaluate their research and help set priorities. And this is our first cut on what this thing is costing. We estimated it was costing about $110 million a year in California at present, in the presence of this program that's controlling it. So it's a fairly serious problem. About half of that is the program trying to control it, and the other half is losses in the presence of the program. So it kills vines, they have to replace them, you have foregone production, and so on. And this is part of the cost. We've done a lot of work now and got a much better measure of these costs, and they're actually higher than that. In spite of us finding that the research program really pays, they've shut the research program down because this thing comes and goes and has been pretty quiet for Pierce's disease. That's a big mistake. And so it's going to be a devastating problem at some point, I think. So it's been a good research program. We've learned a lot about Pierce's disease, and it's become a model disease because spending that kind of money focused on something, you can learn more general things. They've found some solutions. Genetic solutions are the main idea, and I recommend you don't breed ahead, by the way. I say this to my students, they never listen to me when I say that. You'll spoil some things for yourself if you do that. So the solutions they've found are genetic ones. They can do conventional breeding by crossing with native varieties, like the ones that have resistance to phylloxera. And they can do it with biotech. The big problem with both of these solutions is that the industry is quite strange and they resist anything novel. And so these conventionally bred ones have 99.9% vinifera, but 0.1% California native grapes, and that's a new variety, even though it's exactly like Cabernet except for this case. And so the industry is scared of it, won't touch it. So what happened is I got into that, and I'm thinking you've got to model Pierce's disease, you've got to look a long time into the future. What's climate change going to do to this problem? What's it going to do to because the pest depends on the weather. And what's it going to do to the prevalence of the problem? As California warms up or the climate change in other ways, will the spread of this pest become more serious? It lives in lots of plants. It lives in oleanders. It likes them, so it can march down I-5, march up I-5 through the oleanders and make its way to... anyway, so I started thinking about what's happening in climate change, thinking about having to model Pierce's disease 50 or 100 years down the road. And started to learn that there's something going on in the wine industry. So we noticed that there's been a really substantial rise in the sugar content of grapes at harvest. And that could have been caused by changing climate, could have been caused by some other things too. It may have been, the industry's grown a lot, they're growing more premium varieties in different places. And people could have been choosing to make grapes, wine differently. There's a story about wine that wine writers like Robert Parker or James Sullivan for that matter. But particularly Parker is known as somebody who gives high point scores to wines that have full, strong flavours, intense flavours, ripe fruit flavours. One way to get those characteristics is to let the grapes hang on the vine a little longer. You're trading off acid against ripeness and sugar, and so you get, and basically the grapes dry out a little bit, they become a bit more raisiny, and so just everything's more concentrated, including the sugar. So one story maybe people trying to get Parker points. They're doing things different in the vineyard. They get the Parker points, but they get this alcohol effect. It's not something they really wanted, but they get that inadvertently. So we've done a lot of analysis. We got a lot of data. We got one paper published in the Journal of Wine Economics where we analysed lots of data on sugar content of grapes by 17 crush districts in California, different varieties of grapes. And basically didn't find very much going on. And then we got a huge data set from the Liquor Control Board of Ontario in Canada, where they test every wine that's imported, and they test it for its alcohol content. And so every bottle of alcohol, every bottle of wine that's sold in California has an alcohol statement on the label, but we know it's not very precise. We know there's big tolerance, plus or minus 1 or 1.5%. And so it's the idea we want to say what's happening to actual alcohol content to get this Canadian data. We got it mainly to find out what's going on, but then we noticed that there's a difference between what it says on the label and what's in the bottle. So this other question is what's going on with this false statement. And so this paper, Splendide Mendax, is really about this final step in this process. So if you can see that, these things are going up. The top one, now you can look at your slides. You have permission to look at the first slide. Carefully avoid looking at the part. So this basically has a graph since 1980 to 2009, showing degrees of Brix. That's a measure of sugar content of grapes. It's soluble sugar per 100 millilitres. And you get about 0.5. If you multiply by 0.55, you convert degrees of Brix approximately into percent alcohol. So 20 degrees Brix is about 11% alcohol. So what happens here is we start off with red wine at the top was around 22 degrees Brix at the beginning of the period and got up to 23.5 and 24 at the end. And white wine started off lower and ended up close to 23. So the average went up by about 11%. That's the average across all the grapes harvested in California over this period. That's quite a large rise over a fairly short period. And that implies, everything else equal, that we're basically increasing, unless they do something differently, the alcohol content of the wine is going to increase by 11%. Say, if it started off at 12 percentage points, 12% alcohol, that's going to go up by another whole point roughly. So that's a significant rise if that's what happened. And so the question we were asking is that nature or nurture? Is that caused by the climate or something that people are doing in the vineyard? Is it because of park or one thing that happened in California was they planted some grapevines that were not resistant to phylloxera throughout the Napa Valley, the premium wine growing area, and basically that got all killed, and they had to replant the whole of the Napa Valley within the past 25 years or so. They planted with different cloves, different trellising arrangements. So lots of these things they've done may have influenced the way the grapes come out. One of the stories they tell me is that these grapes just ripen later. What's hard to judge is ripeness is judged subjectively by winemakers, and what's hard to judge is whether the definition of what's ripe has changed because of park.
So you said they're ripening later.
Yeah, that's one of the stories. So the harvest, they're definitely harvesting later. But one of the stories when I talk to them is that it's because it's just the way they've redone the vineyard. They're ripening later than they would have with the same climate and everything else.
Because Margaret harvesting earlier.
Yeah. Barossa is about 3 weeks earlier on average than it was 20 years ago. And that's climate change, they say. But in this paper that's published, we ran regressions and found that, as a matter of fact, over this period, we have our measure of climate, which is supposed to be okay for this purpose, is the average of the daily high and the daily low temperature average over the growing period. So we measure daily high and low, take halfway between them every day, average that over the growing period, which is 6 months. It's a different 6 months in the southern hemisphere, and regress sugar content against that and other variables. We find a statistically significant effect of this climate variable on sugar content of grapes, but the coefficient is small, sufficiently so that you need a really big change in climate to cause the rise in sugar content we've seen. And in fact, the temperature actually over this period didn't rise. It's risen over a longer period, and there are other measures that probably have changed also. That it seems that the overnight temperature has risen a bit, the average overnight temperatures, even though the average of the two hasn't changed appreciably. So we observed, incidentally, in this paper these discrepancies, and so we thought we'd take a look at that. But the implication of these discrepancies, the first thought is that high alcohol content is a nuisance byproduct. That it's not something that winemakers actually want, and so that they're rather not admit to it. And there are things they can do to take the alcohol out. They can do reverse osmosis, they can do spinning cone. These guys, I think they're not meant to, but I think they add a lot of water. They're allowed to add water if it's necessary to complete the fermentation, and sometimes these grapes have so much sugar that the alcohol gets so high it kills the yeast, even with the really good yeast that are tolerant of that. And so they can add water to finish the fermentation. So there's actually a website about econometric poetry, and this is my second entry. And this is I'll read this to you since you may not already read it. But too much of a good thing is the title of that other paper. Some wine writers express their dismay over high alcohol Cabernet. Burning coal, says Old Gore, not the high Parker score, is the cause of the rising Beaumet. Still, a 15% Chardonnay would be too hot to drink, most would say. Lower bricks on the vine, spinning tricks with the wine, or a lie on the label might pay. And I could stop there, and probably you wish I would, but there's more. So, we've got all these data, it's a lot of data. Over 16 years, we got actually about 130,000 observations. I think that we threw away some, took out the German Rieslings because they have a lot of residual sugar and they're probably different for that reason. So we've got 91,000 usable samples. So now we're looking at the same question as looking at international data. So they import wine from all over, and we observe various things about the chemistry, including the actual and stated alcohol content. And different countries have different legal tolerances. So the US law, if it's under 14%, you can go plus or minus 1.5%. That's a big tolerance.
You mean percentage points?
Yeah, exactly. So if it's 14, you can say as high as 12.5 or as high as 15.5. That's the range. So you can say whatever you like. If it's 14.1, you can only go plus or minus 1%, 1 percentage point. Canada has only 0.5% tolerance. So, and one of the stories might be that we haven't done the analysis to see what the differences in the liquor laws in the different countries might be. In the US, if your alcohol content is over 14%, you pay an additional 50 cents a gallon federal excise. Now, if you're making $2 chuck in the Central Valley, they wholesale that for about $2 a gallon. 50 cents a gallon tax is serious money. So if you're making that stuff, you're not going to be wanting to go over 14%, I would say. If you're making premium Napa Valley Cabernet that sells for $100 a bottle, you'd only do about 50 cents a gallon. So but this tax, these kinds of policies may have some influence over winemakers wanting to change the alcohol content or change what the label says about it. But if you get caught lying about the alcohol avoiding tax, you'll eventually get into some serious trouble with the alcohol, tobacco and firearms. They gather them together for some reason. So this is describing the data. You're allowed to look at your version of this table. It's hard to see through, but this is to show you that we have a total of 91,000 observations, 25,000 in French wine, nearly 20,000 Italian. About 10% of the data are Australian wines imported into Canada. So we've got a range of countries, but most of the countries we only have a few thousand observations. We've got lots of data on these countries that dominate the world wine industry or the world wine trade. And so this table shows that we're looking at France at the top row, and the first entry says the average in 1992 was 12.5% alcohol, and it says that if you take the average of annual changes, it rose by 0.22% per year, 0.22 percentage points per year. No.
Percent.
That's growth rate, percent. Thank you. Would have been higher if it had done that.
Could be.
Yeah, so the next one is, so you can work out, you can measure growth rates two ways I know about. One way is to just measure the percentage change each year and take the average of that. And that's actually like taking the log of the final value and the log of the initial value and taking the difference and dividing by n. And so that really depends on endpoints. Or you can just fit a trend line, fit the log of the number against time and get the coefficient. And that will miss the endpoints, and so that's subject to outlier effects and regression problems. So we report both these ways of measuring the same idea, and they're different. So the average of annual change is 0.22, and the trend growth rate was 0.46. And then in France, so we measure temperature, we've got our heat index, we measure that at one place for each of these countries, ideally a place close to where the wine is made, but not always. It's hard to get good data. And so in France, we had a little bit of a rise in temperature too over this period. And so the rest of this table got that for everybody. So we've split the world up into the old world wine producers in Europe and the rest of us. And you can see for the old world, we had a rise in alcohol percent, pretty much like France, and we had a rise in temperature, pretty much like France. So there's some story here that if temperature matters, it's contributing something to this. You have to find out how much. And these things are all statistically significant, highly significant things. We've got having so much data is helpful. And then in the New World, we started off with high alcohol content. So you can see one thing you see is that old world wines are lower alcohol, and we've had a faster trend in alcohol in the New World slightly, and not so much in temperature. These aren't weighted either. This is just simple average, and so for the world as a whole. Okay. So we fit a regression with all those data just to regress alcohol content of wine against a constant, a time trend, the heat index, a dummy variable for white, and lots of different regressions in the paper, but this is one that's useful to look at. And then we have these dummies for countries. And so this is saying, yeah, temperature matters a little bit. Or rather, there's an upward trend. Temperature matters a little bit, but if you're going to add a 1% alcohol, you've got to have increase the temperature by 40 degrees Celsius, which is a lot. So it's a statistically significant effect, but it's not very profound. And the temperature didn't go up enough for that to really know. So white wines are about 0.5% less alcohol than red. The default country here is France, which is at the low end. So the default category is French red. And so you see Argentina, so Australia has 0.5% more alcohol than France. Canada, less, it's cold there. And so on.
We explored that a bit, Julian. Obviously, there's the country effect could be teased out further. Hot countries, cold countries, although you do have a heat variable. But it's the New World producers that have got higher coefficients vis-a-vis hot old world outfits like Portugal and what else? Italy.
Spain,
particularly. Yeah.
Italy's hot.
Yes, but what's the coefficient for Italy? It's quite a low one.
It's negative.
Yeah, so I wonder whether there's also something to do with the process of winemaking rather than the viticulture that's involved here. Because new country, New World winemaking is a more sophisticated or more slick processes than Old World. And in fact, they send their winemakers across to the Old World to show them how.
Yeah.
Anyway, I'll just signpost that.
Yeah, and
later.
we pull it apart some more in various ways. One of the things I meant to say and didn't before, that in this table there's... we'll get to it. It's all right. So part of what's going on here with these country dummies is that this is a very constrained model. We're forcing it to go through. And that changes a little bit when the model we actually use is one where we've got country-specific trends. And if you let them have different trends, rather than forcing them all to have the same trend, it works better. And so they make a bit more sense. All of that stuff I'm not really interested in. I'm just trying to deal with that so I can say something about the heat index. And that's our best model, and it basically says that it's not climate. It's not, our measure of climate doesn't account for this substantial rise in alcohol content of wine around the world. That's a model with lots of variables in it. So that leads us to what I want to talk about, which is this false label. It's another table like the other one, except the entries here now, we're looking at same data, but now we're looking at what the actual alcohol percentage was, what was reported, and the difference. And the first column is for all wines from France. The first block is all wines from France. On the right-hand side, we have it sorted into red and white, but they're about the same for red and white anyway. And this says that for France, the average alcohol content was 13%, the average report was 12.9%, and the difference was minus 0.1%. And you think that's not such a serious issue, but in fact, if you look at the whole thing, the average discrepancy for the old world was about that much, but in fact in our data set we have It's about 60% of the discrepancies are positive. They're understating the alcohol content. About 30% they're overstating it. And this is an average of positive and negative errors. So when it's a positive error, it's about 0.4%. They overstate by 0.4. So if you're making wine in Germany or somewhere it's cold, you're more likely, if the alcohol content is low, you're likely to lie up. If the alcohol content is high, you're likely to lie in a negative direction by about 0.5%. So these are substantial misstatements, averaging about 0.5%, depending which direction is positive or negative. And this is an average of those numbers that misleads because you think, well, that's negligible, but actually 0.5% is not negligible. And when we pull that all apart and look at things, it's as though what the old world guys wish they could say, they'd like to say that their red wine is 13% alcohol. They'd like to say their white wine is 12.5% alcohol. People in the new world would like to say their red wine's 13.5% and their white wine's 13. It's about, you add 0.5% for being the new world, that's what people would, they're lying in the direction of saying these things, regardless of what the truth is. That's their tendency. And so that leads to the theoroid, which is that, and I got this theoroid from talking to a winemaker in Oregon, and I was tasting some Pinot, and it said 13.9% alcohol on the label. And I'm tasting it, I look at him and I said, no way that's 13.9, that's way more alcohol than 13.9. He said, yeah, it's probably 15. He said, yeah, we're allowed to say, plus or minus. I said, no. And I said, well, why do you do that? Is that for marketing reasons? He said, yeah. And it was what I was thinking. It's hard to sell a Pinot that said the alcohol content was 15%. People expect Pinot to be 13.5. So that got to be this theoroid, which is that buyers' willingness to pay for wine, it depends on what it says on the label, and things it says on the label. So this is the price depends on what is stated alcohol content. It depends on what variety it is. It depends non-linearly on these things. It depends on that. It depends on what region it's from. It depends on other characteristics, actual characteristics of the wine. And so the producer's profit maximising statement of the alcohol content is going to depend on all those things. And so then the producer has the problem that he's got to choose between telling a lie, and lying is costly in some sense. If you're an honest person, it's just uncomfortable, or you might get into trouble with somebody for telling lies. And you get the other penalty is being away from your optimum. So there's two costs: cost of being not at the optimum, and cost of telling a lie. And I assert a quadratic cost because I know what happens when you do that. And so you say, well, the solution then is to what the stated alcohol content is going to be a weighted average of just a linear combination of the actual and the desired. And so then we can substitute this solution to the optimum. This is just like other things we see a lot in agricultural economics. We can substitute this into the equation for desired alcohol, and we get this model, implied model that says the discrepancy is going to depend on the actual alcohol content in this particular way and these other characteristics. So now we can fit this model and we can estimate this beta, which is a measure of how honest you are. If your beta is 1, very honest. You put all of the weight on the actual and you just say the truth. If your beta is 0, you don't care what the actual is. You put all the weight on the desired. You just tell people what they want to hear. And so we can estimate that, and that's what we do. So another regression looks just like the other one, except this time the left-hand side variable is the alcohol, stated alcohol content, the discrepancy. So we've got all these country effects, I'll skip that. We end up with this one. This is the one we like, where we've got country-specific trends and so forth, just like before, many of which are significant. And the model fits okay, and we've got this coefficient on the actual alcohol content. So everything here is highly statistically significant. It fits really well. and it makes kind of sense. And this coefficient on the actual alcohol is 0.274, which means that the beta is 0.726. It's closer to 1 than 0, so people are somewhat honest. If it was 1, they'd be totally honest. It is. So that's interesting. And so, having estimated that thing, we can infer what the desired alcohol content is for each of these places. This was a transformation which you don't need to understand, you just have to trust me. And so we can say here for France, their actual alcohol content is 13.1, their recorded average was 12.99, and their desired is 12.7 for red. For white, their desired is 12.5. And so we can fill up the table, and for the old world guys, their desired alcohol for red is about 12.8, and for the new world, their desired alcohol free is 13.2, is about 0.5% higher. And for white, the desired number is about 0.5% lower than for the red. So it's kind of consistent with the gross patterns seen in the data. And you get some variation among countries. You get this variation even though we're holding it's the same beta for everybody. We're saying everybody's the same in terms of their propensity for telling the truth in this model. Everybody has the same propensity, but they're different because their actual content is different. So this is kind of summarising all that. This makes sense to me. I mean, it's plausible. It is what I kind of think. But I expect a good French red wine to have around 13% alcohol. So there. I presented this stuff in Italy one time, and so we estimated some other models. I'm not going to show you the other models, but we can estimate a different beta for every country and every year. We've got enough data to do that, so we did. And this is a table of those numbers. And so if you're cheap, you'll spoil the fun. But if you look at this thing and you say, well, which country is which? I was doing this in Italy. And I said, who do you think? Now look at these ones in the middle. They're pretty honest. These ones on the left, they're big lies and they're getting worse. They started off pretty honest, 0.8, and they've gone to 0.6. And look at these people in the middle. They've been pretty honest all along. And look at these people on the right. They lied all the time. Who do you think they are? And the Italians are very nice people. They didn't murder me. But in fact, Italy were the honest ones. And the big liars were Argentina and the United States.
Are you voting for Berlusconi this weekend?
I don't vote in Italy. So we do that for everybody, and I think it's kind of interesting that the big liars, it turns out, one thing that's common among the big liars is that they, I shouldn't use this language, it's wrong, but the people with small betas, is that they are either Spanish-speaking or formerly Spanish-speaking. So Spanish-speaking countries in California are the places that have a big propensity for a small beta.
Not the Mexicans in California.
Well, Spanish monks started the lying in California. So it's something else. This is not in the paper that you can get on the web about this. Doesn't have this stuff about the country-specific betas. And we've got some more data from the Liquor Control Board of Ontario, courtesy of George Saladas, for a smaller data set. We've got, I think it's, how many now? 18,000 almost observations, for which we have a price for each bottle, as well as the other information. So one of my theories is that price matters, that if it's this issue about the 50-cent tax, you're going to behave differently in that part of the scheme than if it's than if you're a very expensive wine. Or there may be something else. If it's maybe this Parker story is really about premium wine. It's not about bag-in-the-box wine. Maybe so. So it's not a very precise theory, but it's Well, this idea that maybe price matters, and it does. So we ran one regression where we just included price as a variable. But this one we've got categories of prices, and so the default category is $10 and less per bottle. And so this first cartridge is 0.077. That says if your wine is $10 to $20 a bottle, then your alcohol content will be higher by 0.077%, and your propensity for lying will be higher likewise. And these numbers just get bigger. As the price of wine goes up, these coefficients on price get bigger. So the higher the price of the wine, the bigger is going to be your desired and stated alcohol content. So that's kind of consistent with some of the story. Okay, so I'm nearly done now, so why am I showing you a picture of cake? So this is a carrot cake from the Nugget supermarket in Aares, actually. So I noticed something else. That there are other things, other places where people lie. I don't know if you can read this, but this is a compulsory food label for carrot cake, and it says the serving size one slice is 4.5 ounces. I was in Canada, and I was in this hotel, and they advertised in the restaurant in this hotel for dinner carrot cake, one slice, and it was only a pound. It was a whole pound of cake was a standard serving of cake. That's a pretty big piece of cake. I saw somebody eat one day. It was ridiculously large. Anyway, carrot cake is fairly caloric, and this is just the serving size of what that is. Okay, and then I see this cake from the supermarket. It was $2. The stated weight of that cake was 7 ounces. The actual weight was 13.2 ounces because I weighed it, and so in fact somebody who thought they were going to get 805 calories and pay $5.69 a pound for their cake would have got 1,518 calories, but much cheaper cake. There's only $3 in it.
There's the externality of the gym fees.
Well, they've got that. So the idea here is there are kind of two prices. It's like with the wine, one price you're paying is the alcohol, another. So this one, you're paying two prices. You're paying for the food and you're paying the caloric burden as well. And so they put up Kabir. So I went and did this. I took the scale, and the guys in the supermarket get a bit odd when they see you weighing their food and taking photographs. So I sent Kabir to do it instead. And,
you didn't buy it?
No.
That's right. I'd assumed you'd taken it back to the lab.
No. Well, actually, we did buy some because we wanted to see. One theory was that this stuff shrinks with time, and they're taking insurance against that. But that piece of carrot there, that was one we did own. That one didn't shrink at all. It held its value for about 2 weeks. It just sat there. So we measured these things for different chocolate cake and carrot cake and things, and highly statistically significant consistent errors, consistently way understating the amount of cake in the box, and therefore overstating the price and understating the calories. We looked at some cookies, the same thing, large errors. And so somebody said, well, the supermarkets are just protecting themselves. These things are hard to measure. Nobody's going to sue you for being generous, but it turns out if they want to, they can measure things. So they can measure ground beef, which is just about as hard to weigh as cake, I reckon. And they pack it and they weigh it. And they've got a unit-specific weight. And beef is cake is more expensive than beef, by the way. It's not that reason. So this is all quite mysterious. But they can actually weigh beef very precisely. And so I think they could apply that technology to cake if they wanted to. And they can get the bread right. They get the bread almost exactly right. So that's a bit of a mystery. So to conclude that this seems to me this rising alcohol content it's not something that wineries want. It's a nuisance byproduct of them doing other things they want, and maybe a bit of a role of climate, but not much. And the majority of cases, the alcohol content is higher than they wish, but not all. And they seem to systematically distort what they say in a way that's consistent with this theory that they perceive that the consumer wants to be told that this wine has certain characteristics. And it might be that, well, I've got a theory I haven't quite worked out that why consumers pay wineries to lie to them about what's in the bottle. It seems that this thing in the supermarket, there may be lots of other parallels for this too if we start looking around. So that's the end of that.
Thanks, John.